Hello, everyone. Thank you for joining. Hope you're having a great experience attending Build from the comforts of your home. My name is Asrar, and I'm a Senior Business Program Manager for Microsoft for Startups team. Today, I'm joined by Aditya Sharma, who is a Program Manager in Azure Autonomous Driving team, and Ben Lannon, who's a Senior Director at Cyngn. In the next 30 minutes or so, you'll learn how autonomous driving startup Cyngn leverages Azure to create a flexible architecture and core universal driving capabilities that can then be deployed on different vehicle types and target different applications. At this time, however, I wanted to remind everyone of our code of conduct. At Microsoft, we seek to create a respectful, friendly, fun, and inclusive experience for all of our participants. We encourage everyone to assist us in creating a welcoming and safe environment. So let me talk a little bit about Microsoft for Startups program to begin with. So Microsoft for Startups is an equity-free program. It's designed for seed to Series C B2B startups. Essentially, we have two pillars designed to help companies quickly scale. The first pillar is about access to technology, which includes up to 120,000 United States dollars of free Azure cloud, powerful developer tools like Visual Studio and GitHub Enterprise, in addition to Microsoft Power Platform, and more importantly, collaboration tools in today's day and age, apparently, like Office 365. We also offer enterprise level technical support and architectural design sessions, along with one-on-one consultations with our engineering teams. The second pillar really then is centered around business acceleration, connecting innovative startups with Fortune 50, 100, 500 customers with a streamlined path to partnership where our startup engagement manager, who is dedicated to helping startups navigate their partnership with Microsoft. In addition to that, we also provide assistance in getting your startup solution listed in the commercial marketplace, so it's available for customers to download or deploy via Azure Marketplace or Microsoft App Stores all around the world. And most importantly, connection to Microsoft sellers, who are then compensated to sell your solutions to their enterprise customers. Now, attendees can definitely learn a lot more about the program by visiting startups.microsoft.com. Having said that, for today's session, I just want to remind everyone that there is so much innovation that's happening with machines, and at the pace at which it's happening, it's unbelievable. We at Microsoft for Startups have a focus program on autonomous driving because machine autonomous or autonomously empowering the machines is really the future. So with that, let me hand it over to Aditya to talk about autonomous driving program. Thank you.
Thank you, Asrar. So hi, everyone. My name is Aditya Sharma. I'm a program manager on the Azure Autonomous Driving team. And so I just wanted to take just 5 minutes of your time here to basically go over some of the key motivations that led us to set this program up. So as we all know, autonomous driving is a complex problem to solve. Some would even argue it's the most complicated technological challenge humanity is trying to solve today. Now, the challenge is compounded if you're an autonomous driving startup, because being a startup, it puts you in a very unique kind of high risk, high reward situation, where on one hand, you have an opportunity to make a very fundamental impact on how people live their lives. Everything from just moving from point A to point B to just infrastructure in cities to the immense potential environmental impact you can have. Now, chasing after this almost next generation technology, it on the other hand comes with the big challenge of being highly resource constrained. And it's really the balance that you have to strike between these two that basically leads to the question of, OK, how can we scale? Right? We're trying to build the sophisticated technology, but we have this challenge of scale, and that kind of becomes the chicken and egg problem, because it's very important in order to get there to have infrastructure that is not only optimized for your workloads across the life cycle of your product, but it's also very important to optimize for cost. And the challenge we're seeing here is that solving autonomy itself is the most complicated problem, like I just mentioned. And the startups working in this space have some of the smartest minds on this planet working toward that, to solving that problem. One thing that can become a challenge as they try to scale, though, is also having to work on figuring out how do we set up this infrastructure, because we're talking about things that are unprecedented, right? We're talking about doing everything from ingesting, in some cases, multiple petabytes of data every single day from a small fleet of cars, right? To then running large scale simulation jobs, to thousands of cores of GPUs for training jobs. And then to these really complicated hybrid type scenarios, for example, hardware in the loop testing, which is scaled by cloud. So all of that requires a lot of resources to be again put in. So you're essentially putting in more resources to save yourself more resources so that you can scale, and it becomes a really complicated challenge. And that's where that's where this program comes in. What we realized working over the last few years, from everyone from like a small early stage startup to large scale auto manufacturers and suppliers, we've seen all of these challenges. We've not only learned about these challenges from our customers and partners, we've experienced these with them, right? So we've grown through these challenges with them, and that has led to Microsoft building a lot of capability and a lot of expertise around those infrastructure challenges, specifically for autonomous driving. And we've been getting a lot of really good feedback from our initial early engagements in the startup community, that look, we, as much as we love working with Azure, and we love leveraging other Microsoft tools, what really sets Azure apart is this access we can get to these industry experts, to these solution experts, where things that could potentially take us months to solve can be solved within days, because these experts have done it so many times with other customers and partners, right? And that's really what led us to build this program. So just quickly about the program, because I do want to switch over to Ben and not spend too much time on this. Basically, you get access to the premium tier from Microsoft for Startups. So you get all the benefits that Asrar just talked about, all that awesomeness, right? And on top of that, you get two very specific sets of acceleration packages almost, right? So on the technical acceleration side, you get one-on-one access, you get one-on-one sessions with our our cloud architects, our engineering teams, our product teams, and that's immense, because you're basically getting direct access to people who are building capabilities and features, which not only you're using right now, but you can have a very direct impact on shaping those capabilities to meet your future needs. And that's huge. And we've gotten some amazing feedback on that. We also have, in some cases, some really good co-development opportunities with our engineers. And access to those AD capabilities that we're building before they're even released to the market. Then on the business acceleration side, obviously, I mean, being any company in autonomous driving is a tough job, right? So anything we can do to leverage the immense sales cycle we have, the sales force we have, and the go-to-market programs we have, and all the networks and connections we have within this space. We aim to leverage all of those for joint customer opportunities, networking, and as well as event showcases in many examples. So I would love for you guys to go to our website, akams/AD Startup, to learn more about what we're doing. But our goal really here is to empower startups in the autonomous driving space and make them more successful. So with that, I am going to hand over to Ben to talk about some of the most insane and awesome stuff within the autonomous driving space that you'll see. So Ben, over to you.
Thanks, Aditya. So let's start off with a video here. Quick video. So here what you see is a collection of some of our autonomous vehicles from the last few years. You see in a variety of different settings, and this is a new project that we took on just recently, where after working with more road-based vehicles, sedans, SUVs, utility vehicles like you see, we had a pilot where we decided to make a sweeper autonomous, an industrial sweeper. And the point of that video was not to show you, I mean, obviously prototypes are not the end goal, but prototypes are crucial to getting wheels on the road and creating high quality real world data. And really data is what's behind the direction and the approach that Cyngn is taking. So we don't look at autonomy in a vacuum as its own disruptor. We see it as part of a bigger revolution that all hinges on data, right? Industry 4.0 is very closely tied into that and really pulls all these pieces together. So for us, being a more software centric company, we look at how can we leverage data, how can we create new data and create new insights so that autonomy doesn't aim to displace or disrupt work as we know it. It aims to improve, to create new productivity, to augment the human workforce, to make them safer and more efficient. And that's really where we see our software working with the machines and with the operations of our partners to unlock new value and do it soon. So where that data comes into play is in our software stack. This is really our bread and butter, right? So the product that we put on our vehicles, we call the core technology stack DriveMod. And this is a very simplified version of that. It would be way too much of an eye chart if I were to try to show you a proper block diagram, and we would need to sign NDAs with everybody, which obviously is not feasible. But this goes to convey that, hey, in this full stack autonomy software, as it's called, there are all these subsystems, and within these subsystems there are components, and the way that you architect this system plays such a pivotal role in what you're ultimately able to achieve with your autonomous systems. And for us and for our customers, the reason we show this simplified version is to say, hey, we are here, we're your providers, your experts in autonomy. All you really need to worry about is that if we work together with our hardware partners, with our vehicle partners, and get the right sensors, create the right type of data from the sensors for the application, we have the software system that results in telling the vehicle what to do so that it can navigate a seam safely, so that it can execute tasks that add value to the operation. And within this, we build this design intelligently in a modular way so that when we need to write code from the ground up because we have a unique use case or a solution for a particular need doesn't exist, we go ahead and do that. But it also opens us up for great partnership opportunities, even within our embedded driving stack, let alone within some of the services that we'll talk about soon with Microsoft and Azure that are pivotal outside of the vehicle. So let's delve into some of the most exciting technology that's in the autonomous driving space and where many of our brightest minds are going, and also helps to convey, you know, how does a machine even operate itself autonomously, right? So at the top here, you might see something familiar if you've been following autonomous driving or computer vision at all. So we have a camera image, we have 3D bounding boxes that are detecting and localizing and classifying pedestrians and vehicles in this specific visualization. And below that, we have a lean vector-based abstracted view of that world, right? So up above, even though you're just seeing a camera, the bounding boxes are actually being generated by a sensor fusion based system. So we have multiple different sensors and different sensor modalities contributing here, which is why you'll notice we have distances to each of these objects, which are very accurate, which would otherwise be relatively difficult to do in just a camera-based system. But this is the view that helps humans to understand best in terms of translating to what the machine needs to see. So then if you look in the bottom half, if you imagine that you had not seen that there was a street in downtown Mountain View in the camera, you could very well apply this abstracted, what we call the world update view, to essentially any driving application, right? If you boil down to these fundamentals of recommended lanes that should be followed that may contextually inform either the behavior of the ego vehicle or of other actors in the scene, and are recommendations, but help guide you in terms of the most likely outcomes of what actors in the scene will do, and planned paths. So you see that kind of green carpet that can occur in whether you're in a mining operation or you're in a warehouse. You're going to try to get from point A to point B with your industrial machine. And all of the actors in the scene, right? If you think of them as cuboids, it helps to classify them. You can assign profiles to the type of classification that you have. But in the end of the day, you really want to know, where is there a thing and how is that thing moving? How do I predict its motion so that I, the ego vehicle, know how to respond to dynamic scene elements in real time? And that's where what here is a red fence, and now we'll jump over to video so you can see this in action. You'll see this adjusting dynamically, right? So here you can see the scene moving. The fence is changing colors for a variety of reasons, right? You have inputs from the map that might tell you, hey, this is an area where we always need to stop. In this case, it's a crosswalk. In a mine, it might be around a blind corner in a tunnel, and you see those fence colors change dynamically based on information it's getting from actors in the scene, as well as their predicted paths come into where the vehicle wants to navigate to complete its mission. So with that level of abstraction, that's a key element into how we repurpose our software to different types of use cases, and we'll get a little bit into how we do that with different vehicles and with fleet level learning here as well. So most of what I just mentioned was focused around drive mod. Right? Like I said, that's the embedded software that goes into the vehicle. Now, it doesn't exactly work that you say, okay, I've got my sensor suite for this vehicle, I've got my computers and my processors, I've got the software stack that enables it to drive autonomously, and you go upload all of that to the vehicle, install it on the vehicle, and say, go drive yourself autonomously, go create value, right? That's not how it works. There's really a symbiotic relationship between that embedded solution and the more enterprise level and data insights that can be extracted from the solution that's out in the wild, which is why we have fleet management systems that range from operational analytics to being able to figure out real-time diagnostics, update routes, see that the vehicles are in good health, and a software development kit, which includes a data pipeline, how you get real-world data out of the vehicles into the cloud, into your servers, so that you can train your machine learning algorithms, so that you can create insights, cover more corner cases, and all of this really has to work together in order to create the type of value that Industry 4.0 promises, right? That data and that data-driven approach that underpins unlocking new business efficiencies. And that's where Microsoft really comes into play. So this is my most offensive eye chart. So let's have a quick look at it, and then I'll simplify it a bit to land the key takeaway. So on the left side, we have the pipeline as it is at our deployment site, so where we would deploy with a customer. On the right is the more development focused side of the architecture, which for the most part runs through our headquarters in the Silicon Valley. So that's why you see some uniqueness there on the right with our development team, our IT department, and doing much of the configuration. But if we ignore that, you can see that our deployment site and our development site are very similar, right? These very closely mirror one another, with the main difference being that we haven't really had the need. We don't think that it's the right approach necessarily to do on-prem storage and deep learning training at our customer facilities. So we do have that option in our own sites, in our headquarters, and that's the main difference that you see here. And where Azure has been pivotal in in this entire setup, this pipeline that you see here, is in enabling us to seamlessly get data off of our vehicles, even if, like was mentioned before, even if it's terabytes of data, petabytes of data. We have a method by which we can physically take solid state drives off of the vehicles, upload them into our drive racks. Then we use the Azure Stack Edge and Gateway solutions to either curate that data and send it up to our cloud storage, or on the development on our headquarters side to do machine learning in the actual Azure Stack modules for smaller workloads, because sometimes it doesn't make sense to push it up to the cloud depending on the workload size. And this whole architecture, this is what lets us get data from our vehicles that are driving near our office, data from the fleet that is deployed with our customers, and get fleet level learning and sharing across our entire product offering, so that we can use data from one corner case that occurs on the other side of the world to inform and define the new releases, the next versions that we push to the drive mod updates that improve the performance of the vehicles out in the field. And it also lets us test in a safe environment in our development facility and have a testing methodology that's indistinguishable from, or a testing ground that's indistinguishable from the deployment ground. So we know once we've validated in our development and testing facility that we have essentially a one-to-one situation where that can now be adopted out in the field. And with all that shared data and the offering being up in the cloud and backed by Azure as it is, we can then offer interfaces to our customers via dashboards and let them filter through enormous amounts of data in a more user-friendly way, so that not only are we gaining value from being able to drive our autonomous product development with data, we're also letting our customers unlock data about their operations that they may never have had access to before. And that whole integrated data software architecture and our decision to really be a software-centric company and not tie ourselves to a vertically integrated vehicle platform is really part of what sets us apart. So by partnering with hardware manufacturers, by being intelligent about, for instance, creating hardware modules that might reduce the amount of calibration that's needed by creating a building block with multiple sensors mounted together, so that whenever you can see the wings here on some of these vehicles in our fleet, so that whenever you move to a different vehicle, you're not calibrating 4 or 5 different sensors to one another every time. You have a single module that's essentially pre-calibrated and enables you to streamline that process. And every time we bring up a new vehicle, every time we do a new calibration, we essentially grow the body of our core technology so that the next one becomes easier and the next one becomes easier. And the spectrum here is growing from small machines like you saw, the sweeper that I showed the video of earlier, to these 15-person buses and heavy machinery that we're scoping out with some of our partners. And finally, the last piece of that puzzle that makes that with us is a little bit different compared to what you might typically think of with autonomy, which again positions us in a unique way, is that the things that I shared with you up until now, I mean, these are a lot of the best practices that if you've been following along in the news, you'll see some of the best names out there, the leaders in autonomy that have billions of dollars of funding. I mean, they would tell you similar stories to what I just went over the last 10 minutes. The difference is that the robo-taxi, long-haul trucking, the highway automation markets that are mostly more consumer focused, and these are the big multi-trillion-dollar disruptions, they tend to be kind of an echo chamber, right? So you have a few of the leaders in the space, they often target more than one of these, talent goes from one of the leaders to the other, and you end up seeing a lot of similar solutions. It's pulling the technology pushing the technology forward in all of these verticals in an exciting way, and we were seeing commercial and industrial applications kind of get left behind. So what we do is we take the best design practices and we're bringing it over to industries that can leverage that technology now, that might have more constrained environments. So when we go and we develop and we train our models based on urban driving in downtown Mountain View in San Francisco, like some of the robotaxi folks do, we're ahead of the curve when we then go to an industrial site that has an order of magnitude lower actor density and slower speeds. And that's really what's letting us create value now and shorten that time to ROI. That's a concern for some of the very far-reaching autonomy verticals. And this is just putting numbers to that, so we won't belabor this, but it's to say, hey, even the quote-unquote smaller autonomous verticals are huge, and the road to ubiquitous autonomy will be a very long road. So we, for efficiency of our resources, are focusing on these industrial and commercial markets. We're creating value with our customers today, and we see a huge potential to grow into down the road. And with that, please come learn more about us, check us out, and we'll turn it over for some questions.
Thank you, Ben. This is great. The IM actually is buzzing with comments and questions. Yeah. Really sort of the theme that we're seeing is around two things. And it would be great if you can comment a little bit about it, which is what parts of technology are embedded and what parts and what requires connectivity?
Sure. So at a very broad level, if it's safety critical, it's probably embedded. So if it needs to happen in real time, if it could impact decisions that the vehicle will make in terms of the maneuvers it takes and its interpretation of the scene around it, those are embedded solutions. I mean, we're talking, millisecond level latencies that need to be achieved there. But beyond that, I mean, there's great value in opening up a lot of the other parts of the data that's gathered, right? So the fleet management, obviously, we don't want that embedded, right? We want connectivity. We want to be able in near real time to tell someone an operations manager who's sitting in an office that, hey, there's an issue with this vehicle, or let them send a message to the vehicle to say, I need you to take a different route than you thought you were going to take. So for the most part, unless it's safety critical, anything that's dashboard analytics related, I mean, we try as much as we can to leverage connectivity and push that up to the cloud whenever possible. And there's also flexibility there because some of the operations that we have don't have constant availability to connect to either 4G or Wi-Fi. So we also have the capability to queue those things and send them up in larger packets later.
Now, when we talk about data and connectivity, we immediately in today's day and age start thinking about AI and ML. Can you comment a little bit around where is Cyngn currently using AI and ML in the solution?
Yeah, so in general, I mean, we're a startup, right? Aditya mentioned a little bit about risks of and so in general, not only are we a startup, we're also working in these safety critical applications. So we want to de-risk our technology as much as we can while having leading edge capability. So where we try to use AI and ML is where we know that it will create value, not where it might experimentally through some additional R&D maybe create value in theory, right? So perception, for instance, computer vision, there is no doubt that has been proven. Deep learning outperforms non-deep learning methods. With that said, there are still concerns over determinism and safety of what are still relatively nascent solutions in deep learning, especially for safety critical applications. So where we do have deep learning or AI, where it ties into, again, safety critical systems, we have a redundant deterministic path, which might be represented by more deterministic calculations as opposed to inference-based predictions, so that if there is some sort of uncertainty or low confidence in the AI, the higher granularity AI path, we have a fallback that can create a fail-safe method, or we have sensors that are very ruggedized, very coarse, but in a bind can help you to ensure that you never come too close to an object that a collision would occur. So that's kind of our approach, our methodology. Use AI where it's clearly going to create value that you can't create without it. But when you do, be sure that there are fallback plans, because this is a safety first industry.
At this time, I know we're a little over time here. I wanted to thank you, Ben and Aditya, for joining us today. Thank you again, and thanks to all the attendees who are tuning into this session. With that, it's a wrap. Enjoy the rest of the sessions in Build, and hope you stay safe. Thank you all.
Thanks, everyone.
Thank you.